Hello once again, it's Mr. Pete, your internet shop teacher. Welcome back to my shop. It's still the middle of winter here in my hometown, and I'm starting another video here, and this is tips number 629 entitled Making a Tiny Arbor Press. But actually what I'll be making is a tiny nutcracker, but I didn't want to use that in the title. Now nobody cracks nuts anymore, but anyway, I am going to put to use the rack and the pinion that I made in the 4 recent videos, and I'll put that on the screen here momentarily in case you have not seen them, but they have been seen by quite a few people. So in this video I'm going to design and lay out on this piece of 1" by 2" by 7" aluminum drop-off. I had a bunch of these. These are the last 2 that I have. And we'll go through all of that, but we will not be cutting these. We will be installing them as I did in this. Matter of fact, it will look something like that. All right, let's begin. Let me show you those other videos real quickly. Here are the titles of my 4 recent videos that cover the making of the rack and pinion and is somewhat related to this video. As I have told you in other videos, this is the arbor press that we made when I was a teacher. There were other versions of this also a little bit larger, and those were prior to Peterson Products. This is a Peterson Products. And I can't make that here in the basement. I don't have the patterns anymore, and probably I don't have machinery big enough to make this, although I might get back to this someday. But for today, what we're going to make is a small arbor press, and it's like this. Actually, it's a nutcracker. There's an outline of it. Now, when I was a high school student, that is 17, 16 years old, we made something like this, and this is the best that I can remember it. So I'm reincarnating that, and it's a nutcracker, and I'll be making it out of this. Again, I don't know if there ever were drawings. Aluminum. This is aluminum, not steel. You see how much you misspeak when you're an old man. A fumbling old fool, muddling along the best he can. A septuagenarian, if you will. All right, I'm off the subject. So I want to lay this out again, and I need to lay it out on the aluminum, so I'm going to go ahead and put one of these is slightly shorter. I used to have a lot of these. 50 of these. They're drop-offs that came from the scrapyard. These are the only 2 full. Anyway, I'll put some dye on this and we'll get back to the layout here presently. I just discovered I'm about out of red dye number 2, so then I remembered, see, you forget things too when you're ancient, that I had this can from an auction, so I went ahead and sprayed this. What I like about this is that it dries much more quickly than the brush type. Alright, while that is drying, let's get down to the business of talking about laying this out and dimensions. You know that I normally work with wood or paper patterns, and I have been accused and belittled constantly about being out of touch with modern technology, and they say, you don't know anything about CAD. You're an idiot. But actually I do. I've been using CAD for over 50 years. That's right. Cardboard aided drafting. Okay. Now sometimes I make a bunch of these as I am developing and thinking about how I'm going to do this. But I previously made this. Now white never shows up in a video, that's why I do not really like it. But anyway, there's the rack, the hole for the pinion, and this helps me to visualize it. Now yes, with Confusion 360 one could have a 3D model, you know, and I wish I could do that. I honestly do, but I can't. So this is my method. ology. Okay, there's some dimensions. They're not all there. Some you can figure out with simple math. Nobody's going to make this anyway, but you get too many dimensions. They used to call it superfluous is the word. Superfluous dimensions if you got too many that are just confusing. Remember, we're starting out with a piece of stock 7 inches long, 1 inch by 2 inch. Okay, there's the basic layout. And the first thing I want to do is to make the cutouts here. That could be done later also, but in order to cut into a corner with my bandsaw, I like to drill a hole. So I'm going to drill a half-inch hole so I can make the turn. About here, 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 and here. Alright, I'll drill those 4 holes half-inch off camera. I'm trying to reduce the length of my videos. I only get 50% viewing. That is, if I have a 20-minute video, the average viewer is viewing it 10 minutes or less. And that goes for all of my videos. So I know they're too long and belabored. I haven't talked much about safety lately, but be sure and wear your safety glasses and work safely. Keep a neat workplace. I keep putting tools away. Well, there's the holes, and I have one last hole to deburr. Now, I made these deburring tools, oh shoot, during the dawn of time, and love them. This one for smaller holes, but I particularly like this one with a big bodacious handle. It's a 6-flute Severance brand countersink, 82 degrees, and it's not made in communist China. But I like to keep my work deburred because this is soon going to go into the milling machine vise. But I'm going to go over quickly now and saw this out. You know what? That work is hotter than a pistol. That blade is so dull. It's not a skip tooth blade, so it's clogged with aluminum, and I don't dare use coolant on this saw. So I'm not so sure I couldn't have milled through that with a roughing cutter faster than what it took me to cut that. The rough sawing is done. I'm back at the milling machine. And these are very uncritical dimensions. I'm just cutting approximately to the layout lines. It's looking fairly good, but already I decided to make a modification. I would like to make this a little thinner right here, which then would allow it to be clamped to a thicker table. After all, this will be clamped to a table. Also, I do not necessarily want to have to tap a hole that deep or this thick, and so I will narrow this a little bit, narrow this. This doesn't need to be strong. This needs to be strong, if it was a real arbor press, that is. So I'm going back to the mill, and I'm not going to show this, but I'm going to take it off to about there and about there. See you in a few minutes. All right, that's looking good. Thinned out a bit. Now, I told you this was a drop-off, and the blue you see down here is not my bluing. It is the original paint that was painted on the ends of the bars at the mill. So you can see this isn't even close to being square. So I will mill that off square. Not that that matters, but I'm going to go ahead and do that off camera. Next, I am ready to drill and bore that 1-inch hole. I have laid out the center and the outside of the 1-inch hole. How did I locate it? Some of it's by guess and bagosh, and I'm going by this. And I forgot how I did that, but laying a sample of the tiny little pinion in place, and then the rack like that. And you can see that I do have a little bit of room left here to mill off the front later on when I determine the final position and tooth depth, because right now I'm as deep as I can go and there's a working depth. Now I could work just the opposite too and go by dimensions, and the dimensions can be determined, but this is the way I like to do it at the high school, because I guarantee you that some of the kids were going to be off on that, and then this gave us that extra margin where we could go and mill this off, so they didn't have to scrap the work after 3 weeks, let's say. They would never finish it then. And then the other possibility was for them to reduce the width of their rack a little bit by surface grinding it, whatever. But I had all kinds of little ways for them to salvage the work, rework it, if you will. Well, I'm going to go over to the mill now, and I'll show you the setup. I'm not going to do all of this because that is shown in the other video. Looks like Medusa's hair. Well, I needed a bit of a rest, so now it's the next day, but let me explain my methodology here before I finish up boring this hole. Now, what you saw me do in the previous clip was to use a center drill and then a 1/4 inch. In other words, I worked my way up. Now, you can see there's not a whole lot of distance here, so imagine using this 1-inch reamer, how far I would have to drop the table, blah, blah, blah. So I tend to like to use short bits, stubby ones when I can, and I do favor the Silver and Deming type that allows me to use smaller collets and not have to change the tooling all the time, which takes so much time, and also if I have to move up and down. So what I've done then to get close to the final size of all things, yes, I used an end mill, and it's not a 1-inch end mill. It's kind of a morphodite that my friend Wayne from Texas gave me, that he said he picked it up at a antique store, but it is not 1 inch. It's about 20 thousandths under. It's just a morphodite size, either that or it has been ground to that size, but it was just perfect, and I used that in the previous video anyway. But that allows me now to go in with my boring head and finish up, take off the last 20 thousandths. Also notice that just about everything that I did here was 3/4 inch. I didn't use this one. That way I didn't have to, as I said, change the collets. So I try to think of things that will save a little time. Alright, now I'll put this in and get it set up. And I'm still on center here, and even though I haven't worked on this since yesterday, you can see that the table is still in the position 0, 0. Should I have to move the table back and forth to change the tooling, which I'm trying to avoid. I interrupt this video for a special announcement regarding this beautiful little Bridgeport model. Make absolutely sure, if you have not already seen it, to watch this video. Let's see how close we are. I think I'm within about 10 thousandths. I like to use this micrometer because it shows up so well in a video, and it's a stirrup. Alright, so I got 11 thousandths to go. And I want to sneak up on that slowly so I do not end up with a hole that's too large and have to scrap the work, at which time I would scrap the video and you would never see this. You may have watched one of my other videos where I talked about the bore right tool, and that was a measuring instrument that I demonstrated that would allow you to very accurately move your boring head into position, because the dial on here, although it's pretty accurate, I still only call it semi-accurate. So I have been working for some months now and had quite a few failures. In fact, I did quit because I just talked about how easily I'm discouraged. And there were some of the samples and prototypes that I made. Well, I may get back to it, but if this is a failure, you never will see it. But this is a foundry pattern that I made, and as soon as the weather breaks and I'm able to get into the foundry, I'm going to make some castings of this. You can see how similar this is, and see if I can make it work and make it simple enough where it is a viable project and not just another waste of time. Now, this is another rather viable way of accurately setting your boring bar. You notice I got about 11 thousandths to go, which means I would have to advance this half of that, 5.5 thousandths. Well, I never go all in one cut as I get near the end, because there's always flexing of the boring bar. Use as sharp and short and stubby and fat and stiff of a boring bar as possible in all your work, not just this. But watch the dial indicator. I'm just going to move it in about 3 thousandths. You see how slowly and accurately I can do that? And by the way, I have my foot on the brake so that the spindle will not rotate slightly, because I got a bit of a torque here, you know, where I could easily move it, because once you lose your perpendicularity and your high spot here, well, you know what I mean. Let me take another cut. And this will be my last cut, I think. Just about. One more little pass. I probably won't even increase the feed. Or the depth of cut, I'll just feed a little slower, and I think that'll bring it right to the right diameter. This is a 1-inch Lufkin micrometer standard. A bit of overkill, I must confess. It doesn't have to be that close, you know, it could be a couple thousandths over and it wouldn't really hurt a thing. There's the actual workpiece. Alright, now it's safe to take out, but you need to do all that final measuring and finessing before you take it out of your vise. Alright, a little layout die here, and I'm going to roughly lay out the slot for the rack. I think I'll lay out this hole for the screw, as long as I've got the plate set up here. Like, ouch! that scriber sharp. I'm sure that you know that all of the dial measuring instruments employ a tiny little rack and pinion. There's the rack, if you can even see it. The pinion, as shown in some of my other videos, is attached to the shaft that the needle is on. And that's just to show you that these tiny racks and pinions can be made very accurately, and you can measure accurately with them, but only really to the thousandth of an inch, but that's closer than we normally need anyway. If you do not have a height gauge, get yourself one. They are invaluable. I didn't say unvaluable, I said invaluable. This is set for 250 thousandths. And now I'm going to mill near that line. I'm going to go right in with a 7/16 end mill all the way until I break into the hole. Now all of that was covered in great detail in the other video, so I won't go too deeply into that. You can go back to the other video. I will kind of rush through this. Remember, that's the working depth. So watch tips 575, and remember the working depth. Well, there's the formula for it, and our working depth is 100 thousandths, but I'm actually going to make it about 1.108 or 110 because we do not want the gears to be fully engaged. We want, or they will bind, and that's what this little section of the video is all about. And that's quite enough fun for today. Time for a nap and then watch the Rifleman. So join me in the next episode where I mill this out to the working depth and put the cover on it, clean it up, drill a hole, make the screw, and all of that. So I'll see you then.